Good morning, everybody. If you think I'm going to come up here and talk to you about Dow's efforts in modeling and process simulation, I'm not. I am going to speak around that topic because we do use those technologies and capabilities, but in the field of optimization, what we would like to talk to you today about is the entire decision process that goes into applying those technologies and certain other things that we do. How do we know what to improve? Why would we improve things? And so that is really the focus of my conversation today with you all. And my partner in crime over there, Mary Beth Seaschultz, is the one who helped me with this. Last year when I came to ARC, I had some movies and some really cool things to show you all, and I don't have those this year because last year was a visioning conversation about the implementation of Focus EMI that we're doing within our manufacturing infrastructure, and it was talking about the future and what we expected out of it. This year, I noticed that the ARC has a visioning and experience. Well, I'm going to talk about experience here a little bit and what I have found. And we're going to start off with what's the case for change, where are we in Dow, and how are we doing things. And by the way, yesterday I sat through a great conversation about internet security from a representative from Universal Studios. And he said, this is how we do it, but we're not telling you have to do it this way, so the same thing applies here. This is how we approach our optimization strategies today, but this is not something I'm telling you necessarily to do. In the past, actually when I first got into manufacturing in Dow about 15 years ago, by and large our optimization opportunities were brought about because we had reactive incidents to things that were going on in the plants. We would have teams come in and fix these emergencies. We also had our standard break fix. And over time, the way our plants might have been built, and I heard some people talk even today about plants that were built to last 20 years. Now we're trying to get them to go to 50 years and heaven forbid 100 years. I'm not sure about that. But the point being is that we needed to start applying different strategies. We wanted to be more proactive in how we ran our plants, but we're losing our workforce. We're losing that generation that built the plants and run the plants. We're trying to do more technology implementation and more development with fewer and fewer people, so we're stretching them out farther across the planet. If you're working in a company that's not having that problem, please come talk to me afterwards. I might like to learn more. So our current activity is around being more proactive with our data. And in the future, as I talked about last year, the future for us is in our analytics and in bringing together all of our data systems within manufacturing to really start to get the systems to start looking for opportunities for us. So I've got a question. If you've been to any sort of leadership forum or self-improvement seminar in the last couple of years, are you familiar with the drama triangle? The drama triangle states that as leaders and as people that are trying to work with each other in these communities and teams, we need to stay centered, and we don't need to fall into a system where we either act as a victim or act as an accuser or an attacker or as a rescuer. And these are all behaviors that as human beings we tend to fall into when we are in certain situations. Well, I'm about to take you through something that looks very similar to this in terms of the manufacturing drama triangle, and so I wanted to remind you of this and explain to you that within a standard chemical manufacturing framework, the plant is usually the victim. The lab is usually the rescuer. I can help you. I can clarify that, and well, they really don't sometimes. And then the accuser might be product development. We told you to make a certain sort of thing. You signed off on it. It is in the specification. Why can't you make it? So I'm going to use this as a basis for my discussion today on how we're going to understand the situation. And so therefore, we're going to talk about the manufacturing drama triangle as a start. Now, when I came into manufacturing 15 years ago, if I talked to the process engineers, they would say the lab never gives them good data. If I walked into the lab would say the process engineers didn't understand the data they were being given. You all have heard this if you're in a process environment. And then, of course, I came out of R&D, and R&D was saying, well, neither one of them listened to us. And so as I studied this, and I got together with some friends of mine, and Mary Beth was one of them, I finally began to realize that the big problem in understanding where our problems really lie had to do with our lack of understanding of process capability, analytical capability, and the tolerances we set within our processes. It's one thing that was missing from the conversation, because when specifications are being set, R&D typically doesn't have a really good handle on what the process capability of the plant might be, especially if the plant was built 20 years ago and R&D is coming in with a brand new product requirement that the plant wasn't built for. And then in the analytical method, everybody knows that analytical methods have variation, and it's not a problem when your specifications are so wide you could drive a truck through it, right? But if you start narrowing those specs down because that is the view of improved quality, at some point the uncertainty in the analytical measurement is going to spill over those tolerances and you can't tell anything. You can't do anything. And finally, in the rapid pace of running run plant engineers through our plants and trying to develop careers and trying to do all this stuff, we kind of forgot things like mass balances and stoichiometries and process capabilities, all of which cause us to go do a study now of what is our true process capability in any given request, what is the true measurement capability, and combine those two pieces of information into a picture that I'll show you in a minute, and also help us to understand where the problems within our processes lie. Do we need to spend money on improving the process for real? Do we need to spend time and effort and money on improving the analytical measurement? Oftentimes it's as good as it's going to get. Or do we need to have a better conversation with our partners in product development and their customers to set the proper expectations for the assets that we have and what they're capable of doing? And by the way, in case you're wondering, there's lots of wonderful books on how to do this out there. I took a picture of one, which is Fault Detection and Diagnosis of Industrial Systems. It's written by one of the co-authors, and it's good information on data and analytics in manufacturing. But again, there's lots of books out there. Now, in understanding our situation, we're going to talk today a little bit about the sweet spot, and that's where you want your plant operating. That's where you want your process capability to be well within your specification limits, and you want your analytical uncertainty not to be bouncing against those tolerances. Out of specification, obviously, is very easy for you to relate. We have different types of error, type 1 and type 2. The type 1 error is an alarm on product that's perfectly good, so we don't send it to our customer. Ooh, we just lost money. Type 2 is we send product to our customer that the analytical said was good and it wasn't, all because we're too close to the tolerances. And so the type of analysis we do in this space is designed to help us navigate that discussion, and it allows us to start to hone in on what we want to do. Now, in our drive towards process optimization, one of the things we want to try to do is we want to try to touch the fundamentals. We want to pay attention to the data that our systems are giving us. And then we also need to touch culture. Talking about type 1 and type 2 errors to an engineer in a plant is a very dangerous thing to do, because that really speaks to the error in their measurement ability, and trying to work them out of that process can be kind of difficult. But nonetheless, if you are pushing your plants and your operations to the limit of your measurement capability and the process capability, it is something that you definitely need to effectively deal with. Okay. Now, Dow Chemical, and probably many of you all, have been on journeys, a journey like Six Sigma. How many of you have Six Sigma within your organization? Please raise your hand. All right. Six Sigma is a great tool set. In the chemical industry, if you're going to apply Six Sigma, there are certain assumptions that are brought about in a manufacturing environment that don't necessarily translate well into a chemical environment. Because chemistry that takes place in our process industries here includes kinetics, physics, a bunch of things that your measurements may not actually be reflective of. And so therefore, in applying Six Sigma tools, you can go methodically down the process to try to do a process improvement, but if you aren't going back and keeping track of the fundamentals and getting the right individual experts into the conversation, you can sub-optimize a part of your process on one end and be very satisfied with your Six Sigma result and have done severe damage down the stream. So we've had to install some things back into the process to make sure we don't do that. We have one of the departments I lead is a fundamental problem-solving group. This is a collection of engineers, physicists, and chemists, and their goal is in any type of optimization discussion we have anywhere around the company is to engage in that conversation early on to make sure that we're minding our fundamentals. Freshman chemistry, freshman engineering in college, because at some point in the discussion, much of the time that gets lost. Chemometrics, we have several engineers. Chemometrics, by the way, for you process control people in the audience, Chemometrics is where process control people went into graduate school and then something went horribly wrong, and they became amazing data engineers. And I've got a group of these people that are very good at ferreting out even the faintest signals within a process problem and coming back and helping us elucidate what the actual problem is within that space. And then also one of the title pieces to the conversation is modeling and engineering modeling. Of course we use that, but we don't do it first. We want to understand the problem. We want to make sure the data supports the direction we're going, and then we go knock on the engineers' doors and waste their time to modeling whatever it is we want to work on. Our analogy here is how can you improve on grandma's recipe for cupcakes if you don't understand the ingredients? And this is actually a theme used in in training our future technology leaders within the company. It's actually a very intensive course. Okay, so we have gone through, I know I've just zipped you right through a process of, oh my goodness, we've made these improvements. I understand that. But what we're doing is preparing a way for the hardware changes and process control. We want the output from these fundamental investigations to give us an understanding of what we need to accomplish for better safety, lower cost, higher yield, and improved quality, and we get to work. Success for us depends on getting buy-in, however, and I admit that we have stakeholders we must feed. We have people that will do the work. There's an enormous amount of collaboration in our model. Obviously, there's politics, but if we've set ourselves up for success here, we have the right series of steps in place, and by the time we get to the let's touch the plant, everybody's in agreement, and we have a good data-based solution for what we want to go do. So in making changes, we have this little build here. Typically in a plant, we have transactional measurements. You all know these if you are in a run plant or you support people who run plants. And their goal is basically to keep status quo. Historically, what we would end up doing, I'm not building now. There we go. We go from transactional to strategic breakthrough. What are we going to do that's going to really improve the capability of our process and by whatever measure you want to see? And this can be changes in how we control the plant, the logic systems. We're looking for this massive breakthrough. There was something that I think we discovered we were missing in this whole conversation, and that's the middle piece. And the middle piece is what we call the tactical. It's the course corrections. It's effectively optimizing the conversation around the data that takes place within the plant, getting R&D more involved in the process of running the plant, getting our tech centers and the folks outside the plants engaged in this. And it's these course corrections and optimizing across multiple variables and phenomena that we don't typically drive the plants on in the transactional space that bring us the greatest value for what we're trying to do. And so this particular slide is sort of the point of the entire discussion today, and I will show you some examples in a minute. So running the plant in the sweet spot means being intentional, measuring the right thing at the right place, on the right time scale, and with agreed upon actions to make the right choices. It's a decision map. SPC is a classic for the plant to run things on, but we have multivariate quality, multivariate monitoring. We also employ lots of engineering models within our activities. We have control plans of actions clearly spelled out and are easily accessible. And this comes from a plant misbehaving. It's out of run plant normal, and we come in and we identify what are the key actions, and then we're institutionalizing that knowledge within the data systems themselves because we're running people through the plants very quickly. We don't have the experts sticking around as long, and all the things you've heard this week in this symposium. We have online analytical and soft sensors, advanced process control, and then finally, across the entire spectrum, complex and relevant calculations that are infused with fundamentals and modeling and brought back into the systems to help us run our plants better. So, in housing the existing knowledge, we are trying to get the conversation going between experts that are basically around the globe. They're no longer sitting individually in the plants because we can't afford to do that anymore. And so the data and process decision maps house the vetted knowledge. And I'm going to show you a few examples here very quickly before I close. It's critical with an aging or functionally or geographically disjointed workforce. The only people that are directly tied to the plant these days are the ones sitting there operating the plant. The expertise for the different unit operations in the plant and a lot of that other activity takes place maybe at a site where we've got one plant, but they're responsible for things all the way over in Thailand or in Germany or over here. Once we've realized the challenges and we start to work with the people, we go through a process of creating our conversation with the folks, getting the buy-in, data to stories, what is needed technically to get the data for the plant to use and stories to data, what is needed motivationally to convince the folks within the organization that we're going to make these changes. And also, it's a great training tool to get people up to speed on fundamentals. When an engineer comes out, a freshly minted engineer comes out of college, their engineering curriculum never challenged them with chemistry fundamentals, or if they did, it was so far back in their memory that it kind of gets dropped. And one of the things we're trying to challenge all our young workforce with today is don't necessarily accept everything your mentor or the chief of the plant hands you without going back and basing it against the fundamental knowledge that you have. And then, of course, we're trying to establish a common nomenclature between R&D, the tech centers, and the plants to ease that cultural transition and collaboration. So the story here is Grandpa tells stories to the grandchildren. Well, we want the grandchildren to figure out how they're going to tell their better stories in the future, which is taking the data and the analytics we have and bringing that into the culture and into the conversation, making more data-based decisions, using the modeling capabilities that we have inherent within the company, and using the other capabilities we have, which are not in most people's mindset coming out of school today because we can't spend the extra 2 or 3 years educating them in this in college. So, it's a culture change that we're talking about. This is not just implementing a software package, and it's not just getting data and dumping it into a dashboard and calling it done. This is about using data to take action, implementing a new way to do technical plant support, requiring a mindset of culture change, and requiring unprecedented cooperation between functions. And somehow we have to institutionalize this in such a way that no one person's responsible for it, because that one person may be moving off to do something else in the environment that we're in. We do not want to use a dashboard with a bunch of information on it. And I'll show you an example very quickly, where there's data and analytics that no one's going to respond to. If you've been in an operational environment that has alarms, how many times have you heard alarms beeping and nobody does anything because there really isn't anything to do about that? And we're trying to drive that out of our processes within our own company. So here's an example. I don't know if you all are aware of this. This is I'm doing an advertisement for LUMO Lift, and they don't even know it. This is coming out this spring. If you have a posture issue and you want to solve that problem, and I heard someone mention this technology yesterday, type of technology, you wear a little pin on your lapel, and if your posture goes out, you get a signal immediately that something is wrong or that you need to change something like this. And this is a classic example of the types of response we want from our data, our analytics, and our modeling. Instead of just coming back and reporting that something happened, we want something to come back and tell you immediately so that then the operational folks within our plants will be able to make that change. And by the way, I think this becomes commercial in April or something like that, in case you want to go out and inspect that. That information is there. So here's some examples. Behind there is a nicely fuzzed out dashboard because there's lots of things I can't tell you, I'm sorry. But nonetheless, we now have people that are looking at information on the dashboard, and it's specific to the role the person has within the operation. And this is Northwest Analytics Focus EMI in these examples. But at one point, you see the control pattern of that data to start sliding out of control. And you would think normally that the plant would do something about that, but you know they're probably not necessarily looking at this. And so it's highlighted for the engineer when he or she comes in for their 5-minute review in the morning before they go off and do all that other work. She goes, oh, wow, I've got a problem here. Takes a look at it, and then obviously they made corrections and got the plant back where it needed to be. And this was done on a time scale of a couple of hours, perhaps, instead of days or sometimes not even noticing the change. I have another example, again, artfully fuzzed out. But if we see that we have opportunities within the plant, we've created decision trees, and behind those decision trees are integrated information and action tools that we can get that is now available to our operations folks that have not been available to them before, and it gives them a better decision-making process within the plant, And this is becoming a wonderful way to transfer information between older employees leaving and new employees coming in. And then finally, my favorite picture, and this is real, one of the tools we turned on, you can tell when we turned it on, by the way, because it's right where that baseline drops below that control limit. But the plant was ignoring this particular signal, and this particular signal has a lot to do with something very valuable in the plant. And if you don't take care of what's very valuable in the plant, you end up having to replace it, and that gets expensive. And once we were able to, along with the tech center that was in charge of this, get the plant to start paying attention to this, all of a sudden their costs dropped through the floor because they aren't having to replace these things anymore. And you say to yourself, well, gee, that's obvious. Well, but it wasn't obvious to the plant until we shine the data light on that. So in conclusion, I talked a little bit about our optimization journey within Dow. It's multifaceted, but it does start with a conversation, and it's a very linear process that we go through, understanding the situation, making the changes. Then after we're done, the newest thing we're trying to do now is keep our plant in that sweet spot and engaging the right resources and giving them access to data that they normally did not have, to making sure that the gains we've sustained are recognized, they are documented, and they're easy to get at from the people in the plant, which then improves our return on our investment. And I am done.